Oh my god, the mosquitoes are bonkers. Ugh. Alright guys, so first things first, I have to replace the cable for my RF lab here that goes from here out to the back corner there. So first thing I've done is try to figure out what the hell's going on here. So let's do this. I'm going to turn on my tester. This is just a basic tester here. Let's run this all the way to the other end of the yard. We're in Canadian summer beginnings, so the mosquitoes are absolutely insane. Oh my god. So that's why my little office tent back here has screens on it, is because the mosquitoes get unbearable. Oh my god. Okay, so this is pretty horrible. Alright, so let's see here. Oh my god, you can see them all flying around, which is a good thing. It's good for the birds. Okay, so let's plug it in and see what happens, okay? Oh my god. Okay. So 3 and 6 are no good. That's my second set. Okay, so those guys are no good, and that's why my outdoor AP isn't working. Which means I need to replace it. And that comes all the way along there over to that cabinet. So I thought, you know what? This is a good opportunity, Sarah. Why not use Moca? So I'm going to run 2 coaxial feeds over there. In that way, I'll be able to use one for power, 54 volts, and one for data. So I've already done the appropriate measures, taken the appropriate measures here. And I have installed a Moca transceiver right here. Because it's going to be fiber coming outside here. I haven't exactly set that up yet, but whatever. So right now I need to get it set up for this. So we're going to pull this cable back because there's clearly something wrong with it. It probably got nicked or chewed on by a critter. We're going to find out. So I'm going to just cut the end off here. And we're going to use this to pull the new cable. I'm going to teach y'all the trick today. Why am I doing this right now? Well, I just finished all of my bookings for the day. And so this is not quite last minute. But on top of that, I want to be able to start working outside after the fires clear. So we're not affected by the fires, but the smoke is actually pretty heavy during the day right now. The plumes just roll through, you know? All right, let's see here. Oh my god, the mosquitoes are insane. Some of you know what that is like. Come on, spiders, do your jobs, you little bastards. Oh, you little freeloaders, eat these mosquitoes. Here we go. So the idea is to free this cable. And I'm going to tie on the coax, the first coax that's going to feed this. Actually, you know what? In hindsight, that might not be a good idea because I need 2 pieces of coax, actually. Oops. Okay, so I think what I'm going to do instead is I'm first going to walk a piece of coax, okay? So let's get this set up. Woof, I'm winded. Alright, let's do this. Over, under, through, or down, or up, or whatever. Alright, there we go. We got our coax on the spool. Now, the reason why I'm using coax is because I can use one feed for 48 volts. I'll run 54 volts from the cabinet here, because if you look inside, I'm actually running separate power into this cabinet from in the house. And so I'll have a breaker for the far end. And yeah, so why don't I do this? This way you can see exactly what I'm doing. I need to get marker tape too, so I'll pause when I go to do that. Welcome back to my backyard, by the way. Alright, here we go. Now, FYI, this cable run is only going to be about 100 feet or so, and I should be able to actually get that off of here. So we're at 119 meters here. And here, we are at 66 meters. So that's roughly 60 meters, about 180 feet. So that's well within what Moca's capable of doing. Now I need to get some marker tape. There we go. So bear with me for a moment. I'm going to run in the house and get some marking tape because I want to make sure I know which one's which. Power and data. And it is starting to rain. So now, for those of you out here, some of you might not understand why I'm running coax instead of Ethernet. And that's because coax is a little bit more resilient and easier to fix in my situation, okay? So what I can actually do is if the coax gets broken or chewed on or whatever, I can simply go back to it, cut it, I'm leaving an extra coil on both ends, and just rejoin it. Real easy instead of doing that with Ethernet. This is 2 conductors. Also, this is a little bit more resilient to damage. So when this cable gets damaged, it's not as big a deal, okay? And I have tested this if you watch my videos. Plus, I want to test the Moca stuff and see how well it does in a real-world outdoor scenario like this. So, we're going to label one of these cables red, and one of them blue. Red for power, blue for data. Where did I come up with those colors? It's arbitrary, okay? So, think about it. 90% of the time when you see Cat 5, it's blue. So if somebody sees blue tape on here, especially somebody stupid like me, you'll probably say, oh, that's probably data. Red? That's hot, that's fiery, that's probably power. So I'm going to go from here with Moca back to a HEX-S from this cabinet where I've got a Tycon switch. And we will connect this, Tycon switch to HEX-S. So I'm going to send the power and data back there. Now, this is where the cool part comes in. This is how we avoid having to rerun the cable. Now, seeing as the cable has been buried here for like, well, not buried, but it's ingrown now, and it's been ingrown for a little while, like 2 years, 3 years. The beautiful thing is I can use the old cable to re-pull, or pull the new cable. And you know what that's going to do for me? I don't have to dig around in the bushes. This will go right where the old cable was if I tape it up properly. Knock on wood. Here comes the rain. And it will pull right through where the cables have been grown in by trees and shrubs and bushes and whatnot and grass. So since that cable's already been laid for a couple of years, the nice thing is that it's already kind of under the underbrush. So now this is just going to pull it straight through if we're lucky. So I'm going to tape it up nicely so that especially this has a nice braided end on it, as you can see, so that it'll just pull it through like an arrow. Alright, so we've got our 2 cables here. Cool. Alright, let's go to the far end and start pulling now. Got it started. So I'm going to pull this a little bit closer. Go to this tree here. Pull from here. And then go to the back, because I'll have a little bit more momentum. Yeah, all the resistance is at the head. So it's taped on there nicely. Gee, it's stuck. What are you stuck on? Alright, now before I get too far, I'm going to go back and just double check and make sure that my guesstimate was right, because you never want to lose the cable end in the bushes. Whew. Nope, we got plenty. Look at that. I'm also going to pull a little bit off here on the spool. Now this is a 550 foot spool, I believe. But there's still resistance there when you pull. So it definitely makes it easier when you spool some off. Alright, so we're going all the way through these bushes here, down to the end, and rain permitting, light permitting, I might actually crib this and get this, the cables connected tonight. Probably not, I'll probably do that tomorrow, because there is rain happening, and on top of that, I also need to make my DC patch-ins, so that still has to happen, right? You can hear the rain now. Alright, I think I've got enough. Just about enough. So it's almost there. Gotta make it over to there. So I might short it temporarily. Bring it down here through the bushes. It'll be the end of the world if I do this temporarily. And then what I'll do is I'll pull the blue one longer. So we're here basically now. So I'm gonna take this cable here, find the bottom of it, and haul it out, because I need to find out where the break is, how it's broken. Part 2 of my adventure. Alright, so we need to create an extension cable here for the power cable that I didn't pull very long enough, but it's probably a good thing that I didn't pull it all the way, because that would have been problematic for the blue. Okay, so we're going to get our stripper, and I'm going to go in a little bit, and then I'm going to go blades down. Alright. Spinaroo, spinaroo, spinaroo. There we go. Okay, so I'm going to make sure that's nice and clear, and then I'm going to get my hermetically sealed end, and I am going to shove it in. Shove it. There we go. So you see that now? You see inside of there? I brought the center, the foam, flush with the interior there, and now I'm just going to stick it in here. Like so. Yes. Alright. Cool. Alright, now this is going to need some dielectric grease in it, so let's see here. First of all, I'm just going to tighten that up and put some red tape on it and toss it aside. We'll do the dielectric grease tomorrow when I actually join the cable up. It's getting late here. It's actually about 9 o'clock, and yeah, I go to sleep early because I usually go to the gym in the morning. I don't know if you guys have noticed, but I've been working on not being a little marshmallow anymore. Alright. There we go. Aha. There we go. Okay, so this one's going to go in the cabinet. This one's going to go outside. I think I'm going to use that infrared camera before I return it to my friend. I will use it outside once I get the load connected to this cable to see how much heat dissipation we see at the joint. And I might actually try load testing it too, just for shits and giggles. So there's our extension cable. Now we need a DC feeder. So I'm going to need a red and black. Let's see here. Red and black. Here are the 2 red and blacks we're going to need, because I'll show you the cable that there, the cabinet we're putting outside. This is the one that's going in the back. So I simply took some cardboard, folded it up, took this HEX-S, stuck it in there. Our coax is going to go on there, our DC on there, PoE out to our Moca outdoor AP right there, and then on the bottom here is where our ports are going to be. So we're going to have Ethernet out to the Moca, and this is going to be where our coax will come in. Or, alternatively, I might stick a second RJ45 there and then do my 2 coax connectors there and just screw them in. That might be a better option, actually, because I'll show you. I think I've got a good idea, because I can actually take a 2-piece joiner with ground and stick it on the inside there, and that'll work very nicely. And then we can just stick this guy in here like so. Yeah, I think I want to do that. That'll make a lot more sense. And then all the cables are going to coil back like so and in. I could probably use one of these guys as an example. Here we go. So I will plug it in like so, and then loop it back, and they can plug into this their connectors, their respective connectors like so, coiling back like so. It's a very tight space, but I have to angle this to make it work, so you get the idea. All right, let's put this guy aside. Yeah, these are those monoprice patch cables. They're gigabit. They're just really skinny, so they move around really nicely. Here's my NanoPi Neo, which is going to be used for iPerf testing and other Linux functions that I require from my networking. And that is going to simply connect into here for power, like so. And I know it'll run it because I've tested this before. Surprisingly, the USB port on the HEX-S actually has quite a bit of current. I think it's a 3 amp. All right, so now That being said, let's get down to the meat and potatoes of things. I'm going to use this tip here. And where's my power connector on here? There it is. Oh my god. There we go. That is so full of lead. It's like heavy. Alright, so we don't need any of these tools anymore. I need the long ones for the big cabinet and the short ones for the small cabinet. Put these guys aside. Let's get some solder, and we're going to cut this. We're just going to take this jumper here. Nice and simple. And I am going to cut it in the middle approximately. Nice, right? Now, let me grab an X-Acto knife. Or actually, no, I don't need an X-Acto knife. I've got this kitty cat claw from Smith & Wesson. Okay, so we're going to do this. This is a beautiful bench knife, by the way. It just, oh, very sharp. I love Smith & Wesson. Like, look at that. See, isn't that magic? That just went through like butter. And then I'll take my pick here, and we'll pick this. There we go, so we've got our positive and negative now. So I'm just going to expose some of this. There we go. There, nice and clean. There's our positive and negative. I'm going to shorten this down just a touch. So, now let's get our other one prepped. Same thing. She's a beaut. There we go. You can hear my bench power supply spinning up and down because I've got this little computer over here running. Wow, that worked a lot better. Had I have done that in the first place? But knowing is growing. Yes. Alright, let's tin these guys up. I don't think I need that much on here, so I'm going to trim this guy back a little bit. Same with this guy. Now, this is a handy little trick for light load on coax. So if you're running like an access point or maybe a set of cameras, this is okay. And when I say cameras, I don't mean like some giant PTZ monstrosity. I'm talking with like major like 30 watt shit, what do you call it, 30 watt infrared. Oh yeah, I forgot about this. This cable does not like to solder. Let me see if I can throw some flux on it. I don't think that this cable solders up. The grounding on it, I think I might have to bind it, and then, which I don't like to do, and then hit it with some heat shrink. It won't take solder now. Should have forgot about that. That's not cool. We'll make do. Don't worry. Now this copper, this will take it every day. All day. Alright, so there's that. So now we can improv. Okay, so first let's do the long cable. I'm going to put this Smith & Wesson back in its holster. Nice. I like this little knife. Alright, so let's strip these guys back a little bit. There's that one. And since I'm going to be binding this one, make it a little bit longer. Alright, so first things first, let's get this guy in here. So I'm just going to do your typical spin it. see here. What's the best way to do this now? You know, that just might work. Just like that. Let's get our positive on here now. As long as it's strong enough that it'll take a tug, everything's happy. Come on. Nice. Alright, so that's nice and strong on there. I'm not sure I can actually get any strength out of this guy by soldering it. I make more of a mess than anything. Now, just an FYI, I have tried contacting wholesalers in China to see if they will make a barrel connector to a UHF connector. And nobody's interested unless I buy about 1,000 pieces. And since this is not something that would commonly occur, I just don't see it as being financially feasible. Now, one of you guys out there feel like stealing this idea from me and doing it instead, and you're capable of actually getting a Chinese manufacturer to produce these things for me, go for it. But hey, if you want to be really nice to me, maybe give me some royalties on the concept. That'd be kind of nice, because hey, we all have to eat, right? Kind of nice. So I'll tell you, it wouldn't be the first time one of my ideas has been used for the betterment of mankind, and I've gotten no accreditation for it or financial compensation or whatever. Even though the species is horrible, it's still good to, you know, do your part. You know what I could probably do? I'm going to double this up. So I think I might be able to first run this over here like so. We're just kind of winging it, by the way, folks. There we go. So I'm going to stick that over top of there now, heat that up, and then put a big piece over there to hold both. By the way, this is glue-filled heat shrink. I purchased it on Amazon. If you look up battery heat shrink or DC heat shrink for power, you will find this. There. So it's a glue-filled heat shrink specifically for this application. So now I should be able to, that should be pretty strong, put a piece of heat shrink over that, and I've got some nice big stuff here. Let's see, that should be perfect. Look at that. Huh? Nice and chonky. Chonky McChonkerson. Now the positive is all isolated, and the braid or shield is still exposed, which is fine. So watch this. I'm going to take this like so. This is just another approach. If you watch my videos, I probably do it a little bit differently every time, because I'm always trying different methods or trying to improve on my practices. So before I put that in there, let me just see if I can mold that a little bit nicer. There. Let's get this on here like so. Alright. By the way, I've started watching this new show called Auntie Donna's, and it is so good. The guys are zany. It's wonderful. I'll maybe put it, if I can get another piece on here. Let's see if I can, here we go. Slip this guy over here like so for a little bit of extra protection. There we go. That should be nice. Another one of these. Oh, this is very nice. This is like Zen garden type stuff. So the inner layer, that's going to work out really, really nicely. The inner layer is just going to kind of bind it. This outer layer will seal it with some nice glue. Sure, this is bulky, but you know what? I'd rather have bulky and reliable than skinny and delicate. Like me. There, look at that. So now, what do we need for this? Give me a second and I'll show you. Pause. Continue. Alright, 16 minutes, okay. Alright, so now these guys here, this one's going to go in the main cabinet, so I'm just going to tin the ends on this so that it can go into the breakers. So I'm going to give it a little bit on there, about roughly an inch. And this way I can tin these and they will go into their appropriate push blocks. I'm using push terminals for these. Shouldn't put the heat shrink on something hot, right? And that makes sense. Too much sense, they say. Make sure that's perfect. That's going to be pushed in, right? So when I'm soldering, I use a little bit of solder to start wetting it. And once it's like bonded to the copper, you can just feed it to it, right? There, it's nice and tinned. Same thing here. Alexa, lock truck. I just realized I didn't check my truck before I came in. There we go. By the way, I drive a 2011, so I modified that, and I did do a video on that if you guys ever want to watch it. There, that's prepped. Okay, so that's cable number 1. So this is going to go into the terminal blocks inside the box, and then this is going to connect to power. This is my power feeder there for the primary box, and then we're going to do the secondary box now. And by the way, I'm recording this on my cell phone rather than all the expensive Anchor equipment and stuff like that I've got, because why not? It seems to be a little bit easier, and the quality is actually pretty damn good. So, yeah. Drink a liter a day, folks. Alright, there's one. And the other one. Make this one a little bit goobery. So what will happen is when I bind them together, I'll literally just line them together, line them up against each other, and heat them so that it just flows and the blob actually melts on, right? Okay, so now again, I'm going to use that little trick, which probably won't last because this stuff will oxidize, and if it oxidizes, then it's going to come apart. So, all right, this is not an awesome coax brand to be using for this application, just so that you know. I guess I can only record for 20 minutes and then it times out. I think it's got 1 minute and 16 seconds left. I might have to dump this the content and then continue the video. Didn't realize I'd filled up my phone that fast. And so here's the first one. Nice little bit of glue in there. Second one. And we're just about out of filming time on my phone. When it times out, I'll empty it and come back. So what I want to do is I want to put my coaxial connectors on the bottom here now. So the idea will be I'm going to stack them. So I'm just going to mark where they're going to go first. I'm going to get a pencil here. Let's see, and I need a little tiny piece of steel, and it just so happens that I've got a little piece of steel, which I'm working on cutting, actually. What I should do is stack them over here, I think. Oh, it's going to be tricky because I've got all this shit right here on the sides. It might be easier if I put them up top here. I'll put them right here, actually. Where do I want to put them? Because I want everything on the bottom of this box. There's my AP. I could actually go under, like this. There we go. I'm going to do one right here. And one right here. So let's pilot this now. All right. Now, let's get the diameter of our coaxial connectors. Use two of these guys long ways out. Those are nice. Let's just make sure that these are the same size. They don't look like it. I want really long ones. I think these guys are longer. Now I've just got one super long one and the rest of them are all shorties. They're little stubbies. Huh. So it'd be nice if I had a bunch like that, but I'll just use these ones then. Okay, so let's get our measurements. Now I can find a drill bit that will match that, or I can even use a stepper bit. I'm going to use that step bit. Let's try this one. A little bit big. I want it tight because I want to thread them in. That is mint. Here we go. Ooh, that might just be tight enough to screw it in. Oh, that'll be sweet. Nice. All right, let's do this. This might just work out exactly the way I was hoping it would. All right, now I just need to get a socket for that. So pause. All right, to continue, this is 7/16 thread, so I don't want to strip it. Now I can hand thread it the rest of the way. And that'll ensure that I don't actually strip the threading. So lucky. This will thread into the plastic beautifully. Right go. That's nice and tight. Tight like a tiger. Cool. Here we go. So now I will have to mark these. Where's my colored markers? I am such a bloody disaster. So we'll go power. Just to make sure, I'm just gonna mark this one red. Obviously I can look inside of it before I do this, but you know, there we go. Power, data. I'm gonna go Moca, Moca. And there we go. I think it's starting to come together quite nicely, eh? Alright, let's thread this on. We need to do a test on this too to make sure that it's good, so we'll do that in a minute. I could test it as a kit. There we go. Let's thread that in there. Now, for the Moca connector, or the Magic-SFP, it's going to be a little bit tight. So the tricky part, I think, is going to be, see, that goes in there nicely, is I'm going to have to make this a loop. So I'm going to have to actually bring it around like that and then down and in. So I'll need actually a little piece of coax for that. And I think I've got some softer coax actually overhead. I do not. Bear with me a moment, I'll be right back. Alright, got a little, it's a bit of a softer piece of coax. So I'm gonna have to come from here. Yeah, so I'm gonna do one end first. Blades down. Forward, reverse, You know, I don't necessarily need to have the hermetically sealed ends on this because that's just going to make it a pain in the ass, so I need a regular end to go on here. Let me grab one. Alright, here we go. Got some regular ends now. Make sure there's no contamination. In she goes. I'll have to clean that a little bit in a sec. We gotta test all this as well before we actually finalize it. So I'm gonna get a pair of tweezers in here and just pick off that tiny little bit of foil because I don't want that contaminating the connection. That's my bad. Whatever. Alright, so we've got our one end. So now what I'm going to do is I'm going to fasten this. That way I can get an idea of how it's going to lay. Hopefully this contraption works. Otherwise I'm going to have to default to fiber, which is not a big deal because I do have the tools to do fiber. I just really want to try this Moca in a long-term setting and see how she behaves, you know? And I'm going to see if I can get my friend to 3D print a better stand for this thing, by the way. So now, I should be able to shape this. So this is going to go like this. Yeah, I can go like that. Cool. Now I've also ordered some of these monoprice gigabit patch cables because I'm going to need some skinny patches inside of this enclosure to make it work. Why don't I use a bigger enclosure? That's a good question. I got these cheap. So I'm just trying to save some money here because I'm not made of money, and in fact, yeah, I need to try to save some money considering how the world economy is going right now. I'm for hire, by the way. Don't forget that. There's a little bit of contamination in this head. Yeah, that's better. Let's hope that this works the way that I'm hoping it will. Crunchy. Nice. All right, so now, let's see if I can squish this down inside of here. Oh, come on. You can do this. Oh, come on. There. That actually kind of holds this thing in here really tight. You know, I'm kind of tempted, not going to lie, to take this board out of the holder and mount it in without that little piece of plastic on it, but let's see what happens. I got a second one of these guys I need to mount on here. So I'm going to take this one out and I'm going to mount a second RJ45 on there. Now the cool thing about these RJ45s, by the way, is that they're waterproof. Or should I say water resistant. So this is the male end. So you take a standard RJ45 and you slip it into here. This is a CNlinko connector, by the way. It's got a compression fitting on the back. Let's see here. I think I need to plug it in to be able to take it apart. There we go. So you've probably seen these on radios like Basecells. These come from China. So you insert your RJ45 head in there, and then it locks it in place. You can remove it with a knife. Doesn't take any of the clips off or anything. It just holds it in place, so it's locked. All right. And then there's a compression fitting up here that the cable goes through. So you just thread this on here, nice and tight. Tighten up the compression fitting. Then you have this beautiful watertight outdoor connector, and then it connects with just a twist lock like that, see? So now I've got a watertight RJ45 I can connect to my access point. I'll have my coaxial connectors on here for power and data, 2.5 gigabits per second Moca. And I'll have a second connector over here. I think I can get two on here. Yep, two will work. I'm gonna add a second one right there. And I've got a second as an aux, which I'll just keep capped in case I want to connect the radio back there for testing purposes. But I think for all intents and purposes, this is pretty much ready. I'm gonna steal one of my bench jumpers here. I'll take this one. I'm gonna use this one to hook up and I'm actually gonna trim this up a little bit. So let me grab my nippers. Yeah, this will work. So I want this to fit just a little bit tighter, so I'm just gonna take off the strain relief here. Oh, I want it sharp to do this so I don't screw up the cable. There. That's nice. Let's grab that Smith & Wesson. God, I like how sharp that is. There, that'll make more room. There we go. That's better. So I've just reduced the amount of space required, clearance for this. So now I can get this guy down in here. I'm going to use this to hold down the coax. There, that fits beautifully. And just temporarily, so I can actually install this thing outside. I'm going to take this guy here and just coil it up down on the bottom there. And then what I'm going to do is, when the proper short cables arrive, I'll just replace this. But in the meantime, this allows me to activate it, so that'll be nice. There we go. Look, I'm using Velcro. Okay, so this one here, we're going to connect it to the PoE out. I want to be able to power an AP with that. This is actually coming together quite nicely. Let's see. Oh, look at that. That's going to be beautiful when it's done. Then I need my USB for the side here. So I will put the USB in there. This should be a nice self-contained little unit. Same thing, I'm going to coil these guys up. I don't need much back there, really. This is just basically so I've got like all the connectivity that I require for my testing and for my outdoor lab and that, because when I'm actually motivated enough, which I'm hoping my motivation finally comes back at some point, there's some neat videos I want to do with radio stuff. And I still have a lot of radio tech that I haven't even tested yet, like the QuickBit stuff, which QuickBit have been less than helpful, to be fair, but I honestly don't think they're going to last as a company anyway, because I don't see any of their equipment anywhere. Nobody's really using them, which is odd, but whatever. I also find it odd that I've reached out to them a couple of times and they've completely ignored me. But realistically, it's not a big deal. It's whatever. Alright, so there is our USB power now for the... This is going to go through here. And this is for this bad boy right here. So that's our power for the NanoPi Neo. And then what I'll do is I can temporarily, I'll use another one of my little jumpers here. These guys here, I've got them all prepped up nicely. And I will just put this into port 4 like so. Plug that in like so. And I think this guy's ready to go now. I can like pop this outside and do whatever with it. But before I do that, I really should power it up. And I should make sure that this HEX-S is fine, that there's no residual programming on it that's going to affect my functionality. So here's a great opportunity to test our DC connectivity. I'm going to connect this on here like so. And let's give it 48 volts. Here, move it up top here. I got a new power supply, by the way. Thanks, Patreons. Actually, 54.4. Enter. Current limit to 2 amps. There we go. And we can fire that bad boy up. And wait, did I not save my power parameter? There we go. Now I need a set of alligator clips, crocodile clips, whatever you want to call them. Let's fire this bad boy up. Oh, this phone is getting hot doing this UHD recording. I'll give her a negative or a positive. Now let's connect these to our terminals right here. There is life. I don't know if you guys can see inside of there or not. Let me turn that off. We've got power. We're showing up at 4.35 watts. Now I can connect this and see what kind of connectivity we've got there. So I'll just some programming and make sure that this guy's good to go. And you can see that the NanoPi Neo is activated as well. As soon as this guy's booted up, we should see some, yep, there's some activity there on the Ethernet port. So both these guys are now booted up and operational. And then of course we've got this connector here for the outdoor access point. Should keep everything nice and dry. So there we go. That's part 2 of the video, I guess. A lot of part 2. So yeah. All right. Anyway, the part 3 will be me out in the yard installing all this stuff and bring it online. Good night. I've got everything in here. I didn't account for the USB cable to be as tight as it is. It's right against there. But what I could actually do is actually just order a USB head and just, instead of having all this bulk on there, actually cut it all off. But this is essentially what we're going to have. So I'm going to just tie the power on just for one more second here. Let it boot up. And we have a grand total of 4 watts. Wow. That's bonkers. So yeah, our power's coming in through the coax on the bottom. This will be connected to the access point outside. So I'm going to have this guy on here like that tomorrow. There's going to be a second Ethernet port here for testing radios and whatnot. Now, the other thing to realize is I've only got one PoE out here, and I'm not going to fit a full-size hex PoE in here, so I'm going to add a gigabit. And I will do this upon necessity, is I will actually take one of these ports here and put an inline MikroTik injector and tie that into the DC bus, and then I will, because I've got the DC bus right here, right? Use it on internally on the port here. I've got a lot of ways which I can power radios regardless. So, but yeah, it's not the tidiest thing in the world at the moment because the cables will be here tomorrow. But as you can see, we now have our NanoPi Neo over here. It's mounted to the lid. This guy here is booting up right now, the HEX-S, and as soon as this guy boots up and activates the USB interface, that will power up the NanoPi Neo. Once the NanoPi Neo boots, the Ethernet should initiate on both sides, and that thing will be connected. We've got our Magic-SFP here. That's probably going to need some configuring once it's actually installed. This is connected to the port down here. PoE has been enabled on that interface. So yeah, we should be rocking. Let's put that over there. All right, come on, boot. Boot. Oh, I see why it's not booting. Look, the USB cable came loose. Sorry. All right, so that's basically that. It's all set up. Do I have something which I can test the PoE with? I think I do. Hold on. Is this a 48 volt or a 24? I'm going to say 24. Here we go. No, oh, wait a second. I know what I can use. Check this out. I'll use this guy to test it. So, got that guy there. And I will grab another cable here from the lab. Let's plug it into the PoE port. Oh, I could have just used this. Duh, hold on. Now you guys get to see it in action. So this goes on here like so. Twist lock. Now I've got my PoE here. Now I should be able to plug this in like so. And look at that. So we've got some PoE. And this is a neat little device actually, because this gives me USB and a 100 meg port. So this gives me 2.4 amps at 5 volts. So what's that? 5 times 2 is 10. 5 times half is that's about what? Come on, brain, do this. 5 times 0.5 instead of 0.4. That'd be 2.5. So that's 12.5 watts you're getting off of this little connector here, and then a 100 meg port right there. You can get these in gigabit as well. But anyway, so I can take this here, plug that in like so, and I can power something with it. But anyway, that's just a way to test the PoE out on here. So for all intents and purposes, love saying that word, this guy's good to go. She's ready to rock. And something else which is noteworthy, by the way, is I could also SFP, plug this in here, and I now have a gigabit SFP cage connected to this NanoPi Neo for whatever purposes I want to use that for. So just thought I'd mention that. And by the way, that is USB 3, so this is a true gigabit interface. Handy, eh? It's good for testing SFPs. So yeah, this guy can now be installed, so I'm just going to close it up. And she will go on like so. And this can be pole mounted. I'm going to take the power off of here. This is going to go in the enclosure at the, you'll see the primary enclosure. Well, you should have seen it in part 1 anyway, but nice tidy little package, right? And there is one last little part to this. Two last little parts to this. Where are they? There's the nuts and bolts. Whatever. I'll find them tomorrow. But anyway, as you can see, we have one more of these right there. Nice and tidy. Power, Moca, PoE, and I should actually label that PoE. There we go. Don't want buggies and stuff in there, do we? Cool beans. Ready to deploy. Good night. There we go. And just to keep it dry, I'm going to stick this cable inside of here and compress it around the cable head. Now, if you guys are doing fiber optics at all on any of your projects, you will learn about a dead-end termination fitting, which the industry term for it is a butt plug. And it is a little orange or red or yellow or blue rubber dead end that goes into your connector or your grommet and allows you to compress onto it to seal it. Alright, so that's pretty much done. And we've got our cables in place. I can haul out the last of the data cable, the old data cable after. Let's go back over to the primary enclosure. Crack her open, get this crimped, and then light her up. Very excited. It's going to be nice actually using coax to carry the power and data for the switch operation rather than having to run the BT PoE to actually energize it. So back over to the enclosure now. And the mosquitoes are no less fierce. Bloody hell. Okay, so I've got this on the one setting on my phone, so that might cut my head off, but I really don't care because the point of this is that you guys can see inside of the enclosure. So let's take a look at this. So first of all, I'm going to unload some stuff. Crimpers, screwdriver, strippers, the rest of the stuff. Alright, here we go. Well, let's get into the enclosure now. So this data enclosure here is used for my RF lab out here for testing the radio equipment, of course, that you guys send me or that I acquired to verify that it works the way that we hope that it does. Okay, so first things first, let's get rid of some of this extra stuff because we've got lots of extra stuff in here that we don't need. Not sure where this one's going. That should be connected to something. Oh, this is going up top here to this radio here, so I'll just put these guys aside for now. Alright, so we've got our data. And we've got our power. So first things first, I'm going to pull the power up and through. Okay, this might be a little tight. There we go. So there's our power. Now I think I'm going to get rid of this cable here so that I can conserve the tiny little bit of space that is actually going through this grommet hole. So I'm going to be changing this up as well to have all CNlinkos on it as well, but of course that's going to cost a little bit of money and I don't want to do that all at once. So we'll be removing the compression fittings from here and actually changing it over straight up to CNlinko twist locks. Not this moment. Might actually just break down and see what's on it. There we go. Now, pop this through here. Now this is one of these situations where crimping this after would have been a better idea, but I'm going to show you guys a little trick. If you take this thing like so, and put a very clean cut in it very carefully, you can ensure that this will bind properly and compress. So now I'm going to pop this back in here. There we go. So now let's get this guy all hooked up. Let me bring this closer so you guys can see better. Da-da-da. Can you see? You can see. All right, let me get out of the way. Get my radium out of here. So we've got our data here. And I'm not sure this door's going to close properly with this on it. I probably didn't think about that properly. I might have to move the switch slightly. Okay, so let's test it out. Oh, that's tight. It's tight, but it looks like it'll work. And an FYI, by the way, this Tycon switch, the ding rail mount isn't as secure as I would like it to be, but anyway. That's here nor there. So now I'm going to punch this into one of our... This one here is specifically for a dedicated 48 volt device, as is this one. So I think I'm going to take this one out, because we don't need this one right now. And this is a lab setting, so it is designed to be changed up. There we go. And this guy here, well, I'll just tuck it away for now because apparently I forgot the appropriate tool to do a pokey to remove. So here, I'm going to put this into a DC bus, negative. So I'm going to go negative here. And we've got another negative. There's a negative. I need a little nail or something. Let's see here. Yeah, it's a nail I need to be able to push that in. Oh man. We'll go around there and grab something in a minute. This is why I don't like multi-bit screwdrivers, by the way. That happens. Take that offline for a second. And I am going to retrieve something to push. I think I need a tiny bit screwdriver to push into that, so let me go retrieve that. Alright, let's continue this now. I got my little screwdriver here. What I need to do is push this in, and that will allow me to leverage that. We'll get my negative in place. And then pop her out nice and tight. Alright, so we've got that now. So we should have power. Let's enable it. Alright, so that's all lit up now. This guy here is connected to the bottom one. As is something else here. So we're just going to put that back in there to rest. And let's go over to the other end. And it looks like the SFP is most certainly online. Good. That's a good sign. So let's go to the other end now. Okay, we should see power on all the devices here now. Yep, we got power on the Amada. And we have power for the Neo. We have power here, and as you can see from the top chatter right there, the SFP is active. We have success, which means now I can go into a meeting, because as you guys know, I'm a full-time consultant. And after the meeting, I will go in and check the settings on here and show you guys how it worked out. But anyway, there we go. I've got 54 volts DC coming back here through coax, and 2.5 gig Moca coming back here through the coaxial connections. So essentially what I've done is taken two pieces of coaxial cable, which are much cheaper and easier to repair, and I'm using them to connect the rear data pack. So I've got my PoE device, my HEX-S, my wireless access point back there, and my switch, all that stuff out back there can now run off of the 54 volt DC from the coaxial line. If it breaks again, no problem. I just cut out the section and I can just patch it up. Here we go.